Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at a very current issue facing many people, and that is the opioid epidemic, and what can that issue help your students learn math? Can we make any connection between math and, unfortunately, the growing opioid epidemic? My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all our students. I'm really excited to introduce our two panelists for tonight, Pat Flynn and Tom Reardon. Pat has been teaching mathematics for 23 years. He's currently teaching AP Calculus BC at Olathe West High School in Olathe, Kansas. Pat's a 2013 Presidential Award winner for excellence in mathematics and science teaching, and he served on the TI-Nspire authoring teams, which was a writer for the We All Use Math Every Day program in conjunction with the television show Numbers. Pat's presented at many international, national, and regional conferences in the areas of technology, calculus, and geometry. Pat, thanks so much for joining us tonight.
Nice to be here, Michael.
And Tom taught at Fitch High School in Austintown, Ohio for 35 years. He served as an adjunct professor at Youngstown State University for the past 38 years. And as a T-Cube national instructor, Tom's worked on the development of the TI Smart View emulator software, as well as the TI-Nspire CX and TI-Nspire Navigator. Tom works for TI in product strategy and development, and most recently worked on transformational geometry Lua activities, as well as ACT and SAT prep. He also does professional development nationally and internationally. Tom, so good to have you with us tonight.
Good to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions you have to Pat or Tom using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded. We'll provide a link to the event certificate of attendance, as well as all of the documents that are being used tonight at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, find your name in the participant window, and in that same window, you'll find an icon that looks like a phone. By clicking that phone icon, you'll receive call-in information, and you can switch from the audio broadcast, which is the default, over to using your phone, which should hopefully clear up any future audio issues. At this point, Tom is going to discuss our agenda.
Okay, we had the welcome and introductions. We're going to be modeling U.S. opioid data for the 84, the 84 CE, and also Nspire, so it works on all those platforms. See how the data was obtained and how the activity was created. We'll perform a linear model of the data and show that step by step, discuss how good a fit it is, and discuss other possible models. Show calculation of percentage error, compare various modeling equations using interpolation, and predict future data with extrapolation. Model the data with a piecewise function and argue which model is best and why. And also at the end, we'll visit a website that has links to all the materials and a step-by-step blog.
Very cool. Tom, thanks. Pat, would you mind talking through some of the expected outcomes for tonight?
Sure, Michael. At the end of this session, you should be able to be more aware of this important social problem, understand how to do this activity with your students, know how to calculate percent error and how to use it, understand the difference between interpolation and extrapolation, learn some cool new features on the TI-84 and TI-84 CE, learn how to graph piecewise functions on the calculator, and the TI-84 CE will be the focus calculator, but the materials also show how to use the TI-Nspire CX.
Pat, thanks so much. Tom, I'm giving you control. Feel free to share your screen.
Okay. All right, so welcome everybody. we're looking at modeling important social issues with data, opioid overdose deaths in the United States. And I always like to start off with a quote or two. So one of the quotes we'll start with is, "I'm convinced that children can learn in more ways than I know how to teach." Doesn't mean I've given up. I just keep looking for those other ways. That's from Stephen Reinhardt. And another one, also from Stephen Reinhardt, "My definition of a good teacher has since changed from one who explains things so well that students understand to one who gets students to explain things so well that they can be understood." And it's a whole different outlook. Again, I remind you the activity is written for 2 platforms, the 84 and 84 CE, as well as TI-Nspire CX. We'll be showing it on the 84 CE tonight, but please realize you can use this on both platforms, and all the materials are on both platforms, so don't panic here. We did create a website that has files for both of them, the student worksheets and PDF, the teacher notes. There's a TI-Nspire TNS file. There's a program for the 84 and CE that both work on both, rather, and a blog was created for this. This is what the website will look like, and we will show it to you at the end and show you what all the links mean so you can get all that information. So let's go ahead and get started. This was a quote from Sports Illustrated this past June. And I'm not going to read the whole thing, but it says, "Imagine if every day in America 171 people died from the Ebola virus, or if every month there were 8 crashes involving 747 airplanes." I mean, it's just astounding. Very, very sad, and something needs to be done. So this problem is not just the mathematical analysis or mathematical modeling, but also the social awareness that needs to be created. So this is graphs that I got from the CDC. I went online. They did a lot of research on this, and came up with some of these graphs and so on. But I wanted to find some specific data. It was very hard to get. So I found a person at the CDC, and I phone called her and emailed her and asked her if she could give me some help. And this just really is amazing to me. So this is the email I sent in November at almost 12 noon to Rose Rudd, and I asked her for this. I said, "I'm a math teacher in Ohio," and so on. And so 16 minutes later, she responds with this email, and she had created a search of the data that I needed, and it's especially for me. And so we also talked on the phone, and I said, I really appreciate you got that information to me so quickly. I said, I'm impressed. And she goes, well, you said you were a math teacher. And I said, when does that ever, carry any weight? So I really appreciated her help, okay? And I'm just telling you that so that if you need to find data, I think there are people out there who want to help you. All right, so let's go ahead and model this on the 84. Again, all of these screenshots and everything are in the PDFs in the blog. So if you can't see them well, you will be able to see them there. So the first thing we're going to do is enter all this data into the calculator. And if I go back here, you really don't want to put all this data in the calculator because students are going to make mistakes and so on. So what I did was I created a program called US Drug Overdose, and it places all the data for you. So if you can get that program on your students' calculators, you'll love doing this. So the program is US Drug OD. So I'm going to go ahead and execute that program. So it places it into lists, and it tells you what values are in what list and so on. All right. So, so if I go to Stat Edit, you'll see that there they are. Okay. So let me just pull those off and show you that, yes, they are exactly the same. Okay. All right, so we're going to set up a stat plot using the data, and I'm going to go through this, and I put this in the student and the teacher version because I'm not sure if students know how to do this or not. So the key presses are here and the results are here. So it says press second y equals, and press enter on stat plots. And we want to turn it on, so I'll press enter. We want it to be a scatter plot, so I'll leave that alone. X lists are from L1, so second 1 for L1, enter. Second 2 for L2, enter. I'm fine with the box and I'm fine with the color. As far as windows goes, normally I have my students choose the window, And there are an infinite number of good ones, some better than others, and there's some that really stink. I'd like to keep this window here for a particular reason, and you'll see as we go along. So I have that window there, so we'll go ahead and graph that. And you can see that it is pretty much the same as that is right there. So we have this data here, and what we'd like to do is discuss, and before we do the regression, let's go ahead and turn the diagnostics on, something I sometimes forget to do and people forget to do. So again, it's second 0 to get to the catalog. X inverse, since this has the A already here, meaning alphabetic, the next key press I do is going to be the alphabetic character. So on X inverse, it's the D for discriminant, or I'm sorry, for diagnostic rather, sorry. And if you hit this about 12 times, you'll come down to diagnostic on, and it says to press enter twice, once to bring it up and once to actually do it. So now we talk about what kind of equation we could use to model this data, and a lot of people go with linear first, and I'm fine with that, but we're going to do several different ones, but we'll go with linear first. And so we'll go ahead and do the calculation. So again, the key presses are here for those people who are not familiar with that. So I'll press the stat and go to the right over to calculate. And I want number 4, linear regression. Now when I'm doing this myself, I would just press the number 4. When I'm presenting to teachers or students, I like to arrow down to it so the students can actually see it, okay? And also notice you can go ahead and grab the screenshot and pull it off there too. So when I press enter, my X lists are L1, Y lists are L2. Oh, I think that's on the next page, by the way. And we want it to store into Y1. Now, some of you know you can go vars, Y vars, function, and so on. But if you haven't updated your software OS recently, alpha trace, which is F4, has all the Y guys. That was alpha trace, F4 has the Y guys. So I'll just press 1 or enter. So it's going to store into there. And then I need to press enter twice, once to hit calculate and once to actually do the calculation. And you can see, again, they're exactly the same. And that put it into Y equals for me, into Y1, and then I'll go ahead and graph it. And you can see how good or not so good of a fit it is. All right, discuss how good of a fit this linear equation is or not, okay, and that hopefully will be a good discussion for the students. Some of the things I would hope to hear is for the first 8 points or so, it's really, really good. It's fair around here, but it really stinks right about here. And you can see that for interpolation, it's not going to be bad, but for going beyond the data, extrapolation, it's going to pretty much stink up the place. So those are the types of discussions I would hope to hear. So what we'd like to do is use this regression equation that we have to approximate what the regression equation or the modeling equation predicts the number of deaths to be. And I do want to point out this is a very difficult topic because everybody's affected by this. But again, if you do this respectfully and handle it okay, again, it needs to be out there, I think. All right, so for the year 2000, I'm going to go ahead and find out what the calculator modeling equation thinks that's going to be. So I'll go to alpha trace where the Y guys live, and Y1 has that linear equation, and I want to evaluate it at the year 2000. So I'm going to do like function notation, parentheses, and then 0 is for 2000, right parentheses. And so according to our calculations, this should be about 8,251 people, unfortunately, died in the year 2000, okay? And so to see how good of a fit that is, one way is to look at the percentage error here. So let's go ahead and do the percentage error. Now, there's 2 ways to get a rational expression. One is alpha y equals is where the numerator and denominator is. You can bring it up that way, and that's good. If you have the most recent OS for the 84 CE, alpha xt theta n also does that. It's a quick key. Okay, again, that was alpha xt theta n. And so we'll do 100, and I'm going to put the decimal point in. We'll talk about that in a minute. Times the quantity. 8251 8,251 was the experimental, minus the actual in 2000 was 8,407. And then we want to compare that to 8,407. Always compare it to the actual data, not to the experimental. And according to this, if we round that to the nearest hundredth of a percent, negative 1.86%. Now, I would like to talk about something here. You'll notice I have a sign on mine. I prefer to have it negative. That means that my prediction was lower than the actual. So I like having that. Some of you may not. Some of you may want to put in the absolute value. I get that. That's fine. Whichever way you want to do it's fine with me, okay? Let me show you why I did not, why I put the decimal point in there. By the way, quickly to get to the beginning of an expression, second left arrow takes you to the beginning and second right arrow takes you to the end. No extra charge for that. I just thought I'd point that out. So if I go over and top this decimal point and delete it, and if I do the calculation now without the decimal point, you notice I get a fraction, which I could convert to a decimal, but I don't want to go through all that stuff. So again, that's the reason why I put a decimal on the 100. All right, for the year 2005, let's see what our modeling equation would predict for that. So again, alpha trace, where the Y guys are, Y1, in this case evaluated at 5 for the year 2005. And according to our modeling equation, about 15,306 people would have died that year, okay, compared to 14,918. Again, we'll do the percentage error. And if you want to, if you're kind of lazy sometimes like I am, you can go up there and take the previous expression, and, well, in fact, we need to do the one that has the decimal point. Highlight it, press Enter to paste it down, and now I can go ahead and just type over. So instead of the 8251, it was 15,306 minus, and then in 2005, 14,918, and then divided by the 14,918. Let me go back up and put that parentheses in there in case I think it would be okay without it, but just in case. And so about 2.6% off, which again, these two percentages are not bad. Now, I'm not going to bore you with doing it for the other ones because I think I did it already. So if you go to the year 2010, this is what we would predict, about 6% off. And in 2015, you can see we're too low by 11%, but we kind of knew that because when you look at the graph, you can see that's kind of the case. And I'd like my students to make those connections and also be able to explain that and interpret it. Now, one other thing I'm going to look at is the year 1999 was on my original data, but I did not put it in for my modeling. I wanted to kind of use that as a test case. So let's go ahead and predict what this modeling equation says for 1999. To do that, it's going to be kind of weird. It'll be alpha trace, go to Y1, and evaluate it at, in this case, -1, because it'll be the year before 2000. And that's how many this predicts. And again, we could do the percentage error. And so it's 6840 and minus, and for that it was 8,050, which we're pretty far off. Don't know what happened there. Hit the wrong button. Sorry about that. And the percentage error you can see is pretty far off. All right, so now once we're finished doing these parts, we're going to enter the answers into a table called Comparison of Various Modeling Equations. It's located on the last page of the document. I think I have it over here. It looks like this, okay? And so what we can do is also discuss what other types of equations you could use to model the data and list the ideas below. So here we would go ahead and put in the actual values, our Y1 values that we got for linear, and our percentage error. And so I already did that, I think, on the next page. So you can see how this is going to match up, because we're going to do several other modeling equations to see how we're doing with this. And we'd like to be able to make a comparison here. So if I go back to the graph, what other types of equations could we use? I mean, this is a wide open thing. Things that seem to work are quadratic, cubic, quartic. Some people say exponential, some people say logistic. Some people say, how about a piecewise function, which we're going to do later on, okay? So the idea in the gift and the worksheets that I give for the students will be in groups, so it's not very repetitive. Everybody did the linear, and then each person in the group will pick either a quadratic, a cubic, or a quartic, so that they're all kind of related there. And then some students might do more than one if they're in a group of 4. But so everybody do a quadratic. One will do a quadratic, one a cubic, one a quartic, and do the same thing we just here. Quadratic will go in Y2, cubic in Y3, quartic in Y4. How clever is that? And then they're going to go ahead and answer those questions there. Okay. So just to show you what those would look like, we're doing on time here. So if I go off here and let me clear the screen and do stat, calculate, and do a quadratic regression on this information. And somebody might say, I don't think you should do that. Well, let's see. Quadratic regression, L1, L2. We're going to store it into alpha traces where the Y guys live, into Y2, and enter once for calculate and once to see it. And that's not a bad R squared there, okay? In fact, it went into Y2, so let's go ahead and look at the graph. And not too bad, okay? So let's go ahead and look at the cubic while we're at it. Stat, calculate. And again, the students would go ahead and do this on their own and answer all those questions and so on, percentage errors, all that good stuff. But we're not going to do that. We just want to see the results. Here, again, I'm going to store it into Y3 and calculate. And again, not a bad R squared, okay? Closer to 1, the better. Look at the graph. This one's going to be in black, I think. Wow, looks pretty good. Okay. And then finally, the cubic. Stat, calculate, and the cubic, or the quartic rather, sorry. I saw somebody post something about the Nspire. This is all done on Nspire on the data and statistics page, which is really, really nice and very, very quick. And again, written for that. So again, don't panic here if you're using the Nspire. This activity is completely written for that as well. Wow, 0.995 for an R squared. And the graph, there's all of them. And, whoops, pulled it away too quickly. Sorry about that, got too excited. And I think what I'm going to do is just turn off the other one so we could just see the quartic, because it really looks good. So I'll turn it off by turning off those equal signs. Turn off those. So now I'll just have the data and Y4 there. And wow, pretty clever, pretty doggone good, I think. So there's our quartic. Okay. So each person in the group will go ahead and answer these questions. What was the year in 2000? What was the prediction, percentage error, and so on. And I'm not going to do that with you. That would be awful to make you see those again. So what they would do once they do that, I want them to collaborate, share their results. So the quartic will share with the cubic and the quadratic and so on. So they can put that data on this modeling table. And you can see how the quadratic fits in, how the cubic fits in, how the quartic fits in, and then ask them, you know, which one do you think is the best? I also asked them to place a circle around the percent value that is the lowest for each year. So, for example, for 1999, it looks like the quadratic has the best percentage error. 2000, it looks like it's the linear that has the lowest. Again, we're going absolute value here, okay? So go ahead and draw those circles here. and then ask them which one of those best predicts the data, and give reasons to support your decision. And this is really where I want the students to talk, and almost, no wrong answers. I'm more interested in talking about how they, what they're talking about here. So decide which of the 4 is the best predictor of all. So here's what I did. I went ahead and looked at the percentage errors for like the linear, the quadratic. I took the absolute value of each of them, added them up, and then divided by 5 to get the average. Same thing with quadratic. Took the absolute value of each of them, added them up, divided by 5, and so on. The reason I did the absolute value is if you keep the signs, you could have one that's negative 50%, one that's positive 50% off, and have an average of 0, and they're awful, but the average is 0. So I went the absolute value. I also took out 1999 because they didn't have that in the data, and I divided by 4 on these here. So I have those on the next pages. And so for linear, with the 5 numbers, average percentage error was 7. Here was 5. Here was like 5, 5.5, 11, 4.5. But look at this, the quartic, really, really good, okay, there. So then it goes on in the activity. It says we'd like to extrapolate, go beyond the data. So I want my students to guess what they think the data will be for year 2016, 17, and 2020. I think this is really important. Let them guess. George Polya, father of modern problem solving, let them be guessers, okay, so that they can go ahead and guess those. And then what we're going to go ahead and do is, oh, that's kind of weird. That went quickly on me. Sorry about that. I want them to guess what they think it's going to be. So I predicted that they were going to go up about 5,000 a year, so that I have something to compare to when I do this. So the idea is I want the students to then, if you did Y1, I want you to predict what it was going to be for these 3 years. Y2, the quadratic, the cubic, the quartic. And then say if it's too high, too low, based upon your guesses, just for reference. So for mine, I just showed you how you could see the linear, quadratic, cubic, how you would do that. And then I pulled the numbers in. And you can see for the linear, my predictions were low. It was very low here. For quadratic, low, low. Cubic, pretty close for here, and for the quartic, close here. But wow, look at how it took off for extrapolation going to year 2020. We hope this is not the case. By the way, one of the things you do have to talk to about with your students is, remember, when we're doing predicting here, we're going with the fact that it's going to continue as it has. We're hoping something comes along and knocks this off, and that means that our predictors are going to be different. But keep in mind that we're going with the idea that the data is going to continue as it has been. So with that, I'm going to turn this back over to Pat, and he's going to do it with 2 different functions. So Pat, let me go ahead and get me to stop sharing my screen, and you can now go ahead and grab the ball, or Mike, if you could grab the ball, because I'm not seeing it right now, and give it to Patrick.
Hey, thanks, Tom. So when Tom was doing the regressions, the assumption that was being made is that all of this data occurs underneath the same conditions. As we look at the data, it appears that conditions changed here in the U.S., sadly. For some reason, more and more people, and again, this is data, but it's really, they represent people, and it's really important to make sure students understand that there's more and more people dying because of opioids. We can see that. So maybe we should better fit this with a piecewise function instead. Like this portion behaves underneath certain conditions, and then once we reach a certain point, I'm going to think about right here, it appears that we change a bit. And so that was this question 16 saying, model the data with 2 different functions, the first part and the second part. Now, we have the calculator generate a linear regression from 2000 all the way to 2010, which is right here. And that really looks linear to me. And that data, actually, when Tom ran the program, it stores those years in list 3. And then the number of deaths for the years 2000 and 2010 are stored in list 4. And we can go ahead and see that, stat edit. And sure enough, here's list 3. List 3 goes from 2000 to 2010. And then lists 5 and 6 are from 2011 to 2015. That seemed to us to be the breaking point. I'm not sure historically what occurred during that time, but it would be definitely interesting for the students to see what changes happened in the U.S. to make this change, what effects, and that's where that big social conscious piece comes in that Tom's going to talk about later. So anyway, what we need to do is we need to go to our y equals screen, and I've gone ahead and cleared out the previous screens, the previous equations, so they wouldn't be confusing us. But like Tom said, you go on the equal sign and press enter, so it's no longer selected, and it turns that equation off. So what we're going to do is we're keeping the stat plot going, and when we look at the stat plot, between year 0 and year 10, I think that's a linear equation, a linear representation there. So I'm going to go linear for that. And I'm really thinking this, I've been doing a lot of quadratics in class. I know the quartic had a really great fit here. I'm thinking maybe a quadratic. So I'm going to do part B after the students have discussed what they think. As Tom said, having the students discuss this is where the real key on this activity is. We don't want to tell students what to do. We want them to discuss and argue their points and justify their reasoning. So we're going to do it with list 3 and list 4. Again, that's going to be this portion of the data, and we're going to store it into Y5. So I'm going to do that as a linear. So we go to Stat, Calculate, Linear Regression, and I need to choose it to be list 3 and list 4. So right now mine are not that way. And if I notice on the number pads, I see list 1 is 1, list 2 is 2, list 3 is 3. So I'll press second and list 3, and then this one will be second, list 4. And I would like to store the regression equation into Y5. So like Tom was saying, alpha trace, that's where the Y guys live, and Y5 is right there. Press enter, and then enter again to run it. We see a pretty good fit, 0.99. And Tom's notes say, do not graph it just yet. So let's go ahead and grab this over here so we can see that information. Now, let's look at the points for the years 11 through 15. I looked at that earlier, and I felt that that was more of a quadratic type setup. So the students, again, would be discussing amongst themselves, what do they think it is? And then we want to generate that equation using lists 5 and 6, because that's where that data was located from Tom's program. And then we're going to store it into Y6. So I think it's a quadratic. So I'm going to go to Calculate and choose Quadratic. And again, I need to change these to L5 and L6. So I'm going to go alpha second 5, and then second 6. And then I want to store that into Y6. So alpha trace, that's where the Y guys are, and 6. Enter twice, and we've got our setup there. Well, I would really, what these screens are is, when I go to Y equals here, it's stored both equations here. And that's no different than what Tom had done earlier, except we were confining the domain, the data, the domain that was being used for those regressions to a specific pieces of information, right? We're using the whole data for linear just from 2000 to 2010, and 2000 to 2011, and we weren't using the quadratic for the whole pieces, just from years after 2011. So Tom's got this really neat setup on how to do this. On the TI-84CE, there's a really nice piecewise that we can type in. And I'll show the old way of doing it as well. If you happen to just have a TI-84 or TI-83, this would work that way also. So what I do is I press Math, and if I arrow up, this is like, as Tom would say, a pro tip. You can scroll down for a while, but if you press the up arrow, it brings you to the bottom of the list. And right above that is piecewise. And when I select that, I choose how many pieces do I want. The arrows are going left and right. Well, this is going to be a 2-piece. So press Enter to select that, and Enter again. And I notice this looks very much like our mathematical notation that we do. So the notations that we have for the calculator are not really getting in the way of a normal notation that students would see. Okay. So what I'm going to do is I want to have the piece up top here to be Y5. So instead of typing in this whole long piece here, instead I'm just going to go to Alpha, Trace, and choose Y5, which really makes that nice. The second piece is going to be Y6, right? I mean, I'm doing linear, and then I'm doing quadratic. Now I'll choose Y6. Now I need to specify the domains. Now Y5, our linear, is going to be from 0 to 11. So what I do is I say 0, and then here's another pro tip. When you go ahead and go second test, that's where you're able to pull in all of these Boolean operators. That's what we see right, oh, it's on the next screen, sorry about that. Right here, I need to say that the domain is when x is greater than or equal to 0 and x is less than or equal to 11. Well, what's nice is I typed in 0. I already have 0 up there. I just have to select less than x, or less than or equal to x, and x is less than or equal to. So I can choose this portion here, number 5, and it'll save me a lot of keystrokes. Yes, you could back through it and do some other things, but this is a really quick savings. Also, Tom showed me just tonight, there's even absolute values as well in our domain. So kind of a nice restriction that we can do with our piecewise to save us some time. So this is one I want to choose. So, whoops, press Enter to select it. And so it says x is, so 0 less than or equal to x, and x is going to be less than or equal to 11. I'm choosing those years from 2000 to 2011 for the linear. Now, for the quadratic, it's going to be x is greater than 11. So again, I'm going to go second test to choose those, and I actually see x is greater than, I choose that and choose 11. Now, there's no reason you couldn't type in, press the variable key for x, then choose the operator for greater than, but it's nice that those pieces are there to save you some typing in, doing some lots of entering. Now, before I graph this, I do want to not display this graph. I press Enter. So when I press graph, all I will see is just the piecewise. I notice this piecewise really, by having Y5 and Y6, utilizing those, I'm really able to see the piecewise a little bit better here. When I press graph, wow, it's a pretty good fit, because again, there's different conditions that are going on here. Now, the other way that you could have done this, if you don't have a TI-84 plus CE, the other way to do this, I'm going to go ahead and turn off this piecewise. And what you would do instead is at the very end of the equation, right? Here's our linear. At the very end, I'm going to just divide by parenthesis, and here's where I say, this is the domain I'm going to choose. I'm saying here's the domain, and I think we said the domain was x was greater than 0, or sorry, x was greater than or equal to 0, and x was less than or equal to 11. So I'm going to pretend I don't have an 84 CE. I'm going to press X, and I'm going to choose second test and choose greater than or equal to, right? Because x was greater than or equal to 0. And then I have to choose second test and choose the logic and choose and. So I've got x is less than or equal to 0 and x is less than or equal to 11. So again, second test, less than or equal to 11. And then I'll close parentheses. And that's the way that's the way we've always done it before this new piecewise came about. I'll do the same thing for the quadratic. X is greater than or equal to 11. So again, it's divide by, parenthesis, x, second test, and I will choose greater than, enter, 11. Close my parentheses, and when I press graph, it does the same thing. Okay. In fact, to verify that, maybe I should go ahead and let our piecewise here show up as well. So we should see the red graph on top of the green and the orange. Yeah. So they're both doing the same, just different ways of representing it. The piecewise is a nice setup to do it. And as Tom said, there's also on the Nspire as well that you can download. So using these, what Tom has the students do is to compute the table on the last page of the document, and this one right here, right? Figuring out what's the difference. That's what this Y7 is doing. That's our piecewise. And notice, not so good in 1999, but sadly, it's a really good fit making the predictions here. We think this is going to be very high, like, you know, boy, Tom had thought maybe sadly growing by 5,000 at a time. This piecewise is predicting pretty high level here. Well, guess what? Tom, who is so nice that they wanted to help out because he's a math teacher, right? And that's code for, you know, we're important people. And sure enough, just a couple weeks ago, new data came out, 2016. I wonder how that would affect our graph. Is our trend line, does it work? Also, maybe we should put in the 1999 as well. So there's a couple things to think about. Let's first enter the data in. So I'm going to go to I'm just going to press stat rather, not second, just stat, and choose edit to get into our lists. And for my scatter plot, I'm going to put in the 1999. And the data doesn't need to be in order. I can type in, you know, for 1999, it would be -1 because the year 2000 was defined as year 0. And so for 1999, it was 8050. And then for 2016, that would be year 16. Oops, got to press enter to enter the data. It was 42,249. And you always ask students, okay, what do you think? Think our predictor's going to hit it? Think it'll hit our regression equations? What do you think it'll do? They make some guesses. Hopefully by looking at the table, they have an idea. Press graph. Sadly, our predictor, right, our line of best fit is under approximating the actual amount from 2016. We had thought, whoa, we're going to be too high here. I mean, on Tom's growing by 5,000, yes, we are too high. But based on our regression, wow, it's growing faster. In fact, you could look at it's growing at an increasing rate, and the rate definitely increased quite a bit here. It's not quadratic here, you know. And that's, you have to really pay attention and really know your students and know if anyone has been, you know, affected by this and be aware of that. Because, you know, you got to have hope that it, like Tom had said, something's going to affect this and make this knock it down, see what's happening. One thing should note, though, is that our regressions did not take advantage of these two data points, right? So maybe if we redid our regressions, we'd find out. Well, I think we can do that. So let's redo our quadratic. And the nice thing about this is I'm just going to redo the linear and the quadratic. But before I do that, I've got to make sure we have the data put into two different lists, right? The linear we had in list 3 and list 4. Oh, pro tip, if you just press the up arrow, brings you to the bottom of the list. So -1 was 8,050. And for 2016, we had 42,249. Okay, now that the data is in there, in these two tables that we use, let's go ahead and do the regression and see what happens. So, stat, calculate linear regression. And our data for our linear is in list 3 and list, actually, let's do the quadratic first since 5 and 6 is already showing. quadratic, we stored that into Y6. So it's alpha trace, where the Y guys are, Y6, calculate. And now we'll also do stat calculate and choose linear. And linear was list 3 and list 4. So again, it's second 3, because the list 3 is on 3, and 4, so second 4, list 4. And the linear was stored in Y5, so alpha trace, Y5, calculate. Now, the cool thing is, on a calculator point of view, the data or the regressions were put here, but
Pat,
yes.
Excuse me, I think you did the linear on Y6.
Oh, you gotta be kidding me.
Yeah, so
yeah, sure enough, I did it twice.
Yeah, you wanted to do it, but didn't change it to quadratic. So.
Oh my gosh, thanks, Tom.
Sure.
Okay, so this goes to show that you always want students, like in classroom, right? It's okay, make an error. Students will always show you, Tom, thank you so much. I will give back my virtual Pez. So calculate, we need to choose the quadratic, that's what we had there. And that would be second list 4, list 5 and 6. So list 5 and second list 6. And we are putting that into Y6. All right, let's see if that's all. Okay, very good. Now let's get the graph and see the difference. Oh, you know what we've got? I did not turn those off. We need to turn off our 2 regressions so we see just our piecewise joining those together. Don't press the clear button. It erases the entire equation. Okay, so when we take those new pieces of data in, it does, notice right here, it does, when we take in consideration a new piece of data, the quadratic does hit it better. Wow. Okay. So, Tom, I think I'm going to pass the ball to you to, let's see, stop sharing, and Tom. Okay. Okay, Tom, I've passed the ball to you to wrap this up.
Okay, thank you, Patrick. Really good job on that, by the way, especially showing the 2 different ways to do the piecewise functions. Because if you don't have the color one, you have to do it the, quote, old way, but still they're very, very powerful. So one of the questions that I would want to ask my students is which was more valuable, or to you maybe, to the people out there, which was more valuable to you, the mathematical modeling or the social awareness? And I'm hoping that the answer is yes, okay, is that it's both. They were both very, very important. So a couple of things I want to point out. First of all, before I forget, I did send out a tweet today, and I mentioned this to Pat earlier, about having this thing on opioids and mathematical modeling, and I got a retweet from somebody that just shocked me. My son, Josh, who is a pharmacist, retweeted this, so I didn't even know he was following me, and he retweeted it. So I thought it was kind of cool that his idea of the pharmacy and the opioids, so I was kind of impressed by that. So I did have to share that with you. But for those of you who are doing the 84, this is what the teacher notes will look like, and those are really the ones that are on the blog. So you can see all the answers there, all the screenshots are there explaining what's going on. Those of you doing Inspire, you can see it's a very similar looking activity, except now the screenshots are very different, and we're using the data and statistics to show this, and we do a piecewise function and so on. So here's the student version, and here is the teacher notes solution. And they have a lot more screenshots and answers showing you how to do that if you're not comfortable with that. And we do not have 2016's data in it. That only happened within the last week or so, so I did not include it. And here's the kind of powerful stuff here on that. So just make sure the people see you can get it on all platforms. I also want to share with you the website, okay, and the website, I think I have it here. Let me see. There it is. I'll leave this up for about 10 seconds. Those are all lowercase except for the U.S., bit.ly/opioids, and then capital letters U.S. If you need that, you can email me, or I think Mike might even send out in an email tomorrow where you can get this information. So you've got like 3 seconds there to get there. And maybe I'll show this back up again at the end. Have other stuff? So that's what the site looks like. No, I think that's it. So let me go to the website. This is it. If you would click on blog for this activity, it would take you here, okay, and here is the U.S. opioid overdose, and it shows you, step by step how to do this. If you click on the Ohio one, this is a very similar activity, except it uses Ohio data, and I saw we had some people on here from Ohio. So you can get all the same information. It's on for the Nspire and the 84 and all that other good stuff. There is also, here's where you can get the files. Now, when you do click on this, you might feel like, oh, you got an error because of how Dropbox is. So when you see this, this funny-looking horse, you say, oh, it can't be previewed. I made a mistake. Just download them, okay? That's all you need to do there. And then if you click on the get these files for Nspire, again, the same thing there. And on the 84, you get the PDFs of the student and the teacher, and also the program. The Nspire, you get the student and teacher PDFs and also the TNS file. Another thing we didn't get to do, or nor did I want to try to do, is the New York Times put together a 2-minute video explaining the opioid crisis. Which is, if you'll go to there, this is it, okay? It's very, very well done. It'd be something I would show in my classroom. So you have that link if you want to look at that, or just for your own. And also, since it is Pi Day tomorrow, I've done some Pi Day activities, so I'll share those with you. So as you know, it's also Einstein's birthday. And so here is a bunch of resources, jokes, riddles, activities for the 84, activity for TI-Nspire. If you're interested in that, it's there, and those links there as well. So I do want to show 2 other things since we have time. One of the things that I was doing tonight was dragging screenshots off of the 84. And if I was on a smartboard or interactive whiteboard, if I put my finger on this and pulled it off, it would go into my smart notebook. Mike said it would be a good idea to tell people that will also drag into Microsoft Word. I think it also goes into like PowerPoint, things like that. So it's a real quick way to get screenshots. Just drag and drop with either your mouse or with your finger if you're using interactive whiteboards. Also, a lot of people forgot or maybe aren't realized that you can do the same thing with Nspire. Okay, so if I wanted to pull this screenshot here on Nspire, you can't grab the screen, because the screen's interactive, remember that. But there's an imaginary border right around this that if you click or put your finger on it, you can click into. So I'm going to put my finger right here, right next to it, click and drag, and there it is, okay? So again, how I did that was if I go to another page, advance to another page. In fact, let me just advance a couple here. If I do this, again, I can go on this imaginary border around it, pull it off, and drag and drop. And so that can be done into Word or any interactive whiteboard thing there. Okay. Well, you guys have been a great audience, I guess, because I haven't heard anything from you. So I guess you all deserve a Pez. Yeah. So there's my Pez for you. That's the original Pez. The reason I started with Pez was because of Seinfeld. Those are your Seinfeld people. Seinfeld used Tweety Bird when George's girlfriend was playing classical piano, put it on Elaine's lap. She started laughing, and that's when I decided to start using it in my classroom and also for talks. So I hope this was worthwhile for you. If you have feedback, please email me. I would love to make this better or whatever. I appreciate Mike sponsoring us and Pat for going along with me on this. So yeah. Good job, everybody, and I'll turn this back to Mike. There you go. There you go.
Thanks so much, Tom and Pat. If you do have any last-minute questions for either of them, please feel free to try and get those asked. I know they'll do their best to try and get some of those questions answered. When you leave the webinar tonight, a brief survey will automatically appear in your browser. We'd love for you to share your thoughts in that survey. We definitely listen to your thoughts and your ideas. It definitely helps us plan future events as well. Tom mentioned Twitter tonight. Feel free to continue the conversation. So one of Tom's tweets was retweeted by his son. I think I saw, Pat, you had retweeted, I think, one of my tweets tonight. So feel free to, again, continue the conversation. If there's things that you like tonight or questions you still have, feel free to use social media to get those questions answered. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link for the documents that were used tonight. And if you happen to miss either of these links or if it's not working for you, feel free just to wait a couple days and you'll automatically get a follow-up email. In that follow-up email will be links to that certificate, links to the documents, and links to the recording as well. If you're watching this on demand, just copy that link into your favorite browser to receive your certificate. So what happens if the webinar ends tonight and you wake up in the middle of the night with just a really burning question? Feel free to give us a call at 1-800-TI-CARES, or if it's in the middle of the night, maybe better, send us an email at ti-cares@ti.com. So there's that link again that Tom had created in case you missed it the first time. Again, it'll be sent to you in an email in a couple days. Feel free to copy it now or hang out and wait in your email for a couple days. But either way, thanks so much, Tom and Pat, for everything you created and shared tonight. We really appreciate it.
You're very welcome,
all fun.
Michael.
And thanks again, everyone, for attending. Happy Pi Day, and we hope to see you back online next week. Have a great night.